So this is the first video of chapter 4 on Newton's second law of motion. And I break this into quite a few different topics, but they're all interconnected and most of them are all really short. So you're going to need your blue packet as well as you're going to need your orange packet because we're going to finish going over the preconception sheet. You don't need it for the very first topic. You're going to need it for, I think it's topic number 5. And we will need the doodle note sheet that has the Newton's laws in it. I didn't put that on this slide, but you will need that because we're going to do Newton's second law and we'll also add it to the summary sheet. So a lot of topics in here. We're going to be talking primarily about acceleration, forces, and drawing the free body diagrams. While we've been using them, we have not actually been drawing any of them. So the first topic we're going to cover is the fact that unbalanced forces cause acceleration. And this should already be somewhat familiar to you because of the past lessons that we've done. We've kind of been building up to this whole concept and idea. But let's look into it a little bit further. So you're starting on your student note sheet, blue page 6. And let's just think about what we already know. So what is a force? A force is a push or a pull. We know that force is a vector and that it needs a direction. What do we know about acceleration? We know that there are 3 ways to accelerate. We call it speeding up, slowing down, and changing direction. And what do we know about the motion of objects? So we had these in chapter 2. We had little free body diagrams like this. And some of the things that we noted in chapter 2 is that the forces tell us nothing about the direction of motion. Remember, we had questions that asked us which of these could be moving to the right, and the answer is all of them, because looking at the forces tell us nothing about the direction of motion. We also recognize that objects at rest have balanced forces. So if the forces were balanced in opposing directions, we know that they would be at rest. And objects in motion at constant speed in a straight line, which we now also know as constant velocity, also have balanced forces. So we're trying to head towards the idea about acceleration. So let's examine these one by one. So looking at A, we're going to try A, B, C, and D. We're going to try to determine which ones have balanced forces and which ones don't have have unbalanced forces. So you should be able to tell by now that A is unbalanced, B is unbalanced, C is unbalanced, D is balanced, and E is unbalanced. And so I just made X's in the table here. So we already know that the only one that could be at rest or at constant velocity is going to be letter D. So let's kind of look at the ones that have unbalanced forces a little bit further. So I'm only concluding these A, B, C, and E in your table since we've already determined that D is balanced, and so it must be at rest or must be at constant velocity. So now I wanted to think about the direction of the net force. So in this case, we're just going to use right, left, up, or down. So for A, what direction is the net force? And what about B? And then C? And then E? So this is what I wrote. I wrote A was up, B was down, C was up, and E was down. So now, what I'm going to tell you, very important point here, is that the acceleration vector is in the same direction as the net force. Okay, key important information here. So I think you're already on page 7 in your student notes. So now that we know which direction the net force is, we also know what direction the acceleration vector is. So we're basically going to just copy the information from the one column over to the next column. So the direction of the acceleration vector for A is up, B is down, C is up, and E is down. So things accelerate because there is a net force acting on them. Okay, this is just like when we were talking about the unbalanced forces back when we were considering Newton's first law of motion. So let's look at applying this and what can we understand about some of our scenarios. So On page 8, we've got a couple scenarios to investigate. So number 1, look out below drops a 5-kilogram fat cat off the high dive into the pool below, which on this occasion is filled with water. Upon entering the water in the pool, the cat encounters a 50 Newton upward restraining force, and he had a 50 Newton downward force. So which one of the velocity time graphs best describes the motion of the cat? And accompany your answer with a description of the cat's motion. So initially, the cat is going to be falling downwards. So his velocity should be heading more negative because he's going down. So that could be this one or this one, right? This one is saying that he's not moving at all, which he doesn't, or falling at a constant rate, which is not true. So then once he enters the pool, he has a 50 Newton downward force and a 50 Newton upward force, which would mean he was balanced, which means he's no longer changing velocity. So in that case, this can't be, because this would indicate his velocity would be moving in a positive direction. This one would be correct because he's balanced forces. So again, for the first part of this, the cat is going to be having a downward velocity. His speed is going to be increasing, and then after he hits the water, it's going to be balanced, and so he's going to be at a constant speed. So B is the correct answer. So we've got some descriptions here, and you can pause the video and copy any of that down. Then number 2, which of the following dot diagrams best describes the motion of the falling cat from the time that they're dropped to the time that they've hit the ground? The arrows on the diagram support or represent the point at which the cat hit the water. Support your answer with sound reasoning. So before the cat hits the water, he's going to be accelerating due to that 50 Newton downward force, because that's the only force acting on him. And so that kind of rules out tape B because this is all constant velocity. After he hits the water, he's going to be at a constant velocity because he's got balanced forces. And so that's going to rule out tape C because that's not what's going on here. This is not constant velocity. So the only option is going to be tape A. So tape A corresponds with what's happening to the cat. So when he speeds up here, and then he's got constant velocity here. So then number 3, several of Luke's friends were watching the motion of the falling cat. Being physics types, they began discussing the motion and made the following comments. Indicate whether each of the comments are correct or incorrect and support your answers. Comment A, once the cat hit the pool, the forces are balanced and the cat will stop. Well, no, the cat's not going to just stop. When you dive into a pool, you don't just stop moving, right? But your forces are balanced, but it's going to stay in motion and continue in motion in the straight line at that same speed. Comment B, upon hitting the pool, the cat will accelerate upwards because the pool applies an upward force. No, the cat is not going to accelerate upwards and move upwards into the air. He is actually, he has 2 forces of equal magnitude. They're balanced. An acceleration would require a net force. Then C, upon hitting the pool, the cat will bounce upwards due to the upwards force. I don't think the cat's going to bounce upwards, so no, that's not the case. So you have balanced forces on the cat, so the cat's going to keep moving at a constant speed in a straight line. So your follow-up work here is going to be going back into MOPAP Part 2, for Newton's laws, and it's going to be number 3. But first, I want to do a couple of examples so you can kind of see the kinds of problems you're going to be getting. So this first one, a downward moving elevator is slowing down. Which of the following force diagrams could be representative of the forces acting upon the elevator? Arrow represents forces, length represents the size of the force, include all that apply. So it's moving down and it's slowing down. So if that's the case, which direction is the acceleration? So you've covered this previously. So this is going to mean that the direction is going to be upwards. And what does that tell you about the net force? The acceleration is up, the net force is up. So that tells us we've got to find all the ones that have a net force that is up. So of these options, which ones do you have? I'm thinking it's A and C. The other ones either are balanced or have downwards. So I believe this example is in your packet, so you can write any information that you need for this. The next example is the oil drop diagram shows the motion of a leftward moving object. You know it's moving left because there's an arrow here. Which force diagrams are consistent with the oil drop diagram? Arrows represent forces, arrow length represents the size of the force, and include all that apply. So if it's moving left and slowing down, which direction is the acceleration vector? It's going to be to the right, which also means the net force is to the right. So which ones are those? So if we take a look at this, our net force to the right is A, not B, not C, not D, but E. So I get A and E here. So now you're going to want to be able to go to NL3, turn in the normal screenshot that contains all of the information, your name, your ID, your teacher ID, and your success code. So you're going to have to go back to the main menu, the ribbon, and do the manage codes. And email me if you get stuck. I'm thinking you're going to find most of these pretty easy. So good luck.